So let me tell you how we will approach that huge topic, which is around cloud migrations and the risk attached to cloud migrations. The purpose today is really to offer you a view of a structured approach to cloud migrations and the way you can leverage performance visibility to lower the risk attached to those migrations. So we'll first cover really what's at stake. So why are we talking about risk attached to cloud migrations? What are those risks and what should we consider? And then we'll go through the different steps that needs to be taken to secure cloud migrations and how a visibility solution like SkyLIGHT PVX can actually help you go through those steps in the fastest and safest way. And then I'll explain exactly why SkyLIGHT PVX is well suited to do this. So what's at stake? Why are we talking about cloud migrations? And why are we talking about risk when we talk about cloud migration? Well, the first thing and the first fact is that quite a few cloud migrations actually go wrong, a fair number of them. If you consider that statistics, which is about the two main cloud providers, Microsoft Azure and Amazon Web Services. In one case, 43% of the migrations are either stalling or failing. And in the case of AWS, it goes up to 57% of the migrations actually failing. So it means that the majority of the cloud migrations actually fail, or people or organizations actually fail to adopt cloud technologies. So why is that? Why is that? I mean, what kind of issues are we facing when we migrate to the cloud? So there are two main issues. Number one is migrating complex applications to the cloud is the first problem people encounter. So when the structure of an application is complex, correlates with the failure in the cloud adoption. The second one is the fact that when they move to the cloud, a lot of IT organizations actually lose visibility on how their applications are delivered. And that's the second, basically, difficulty. And what is causing those issues? For most people, when we debrief on what is the cause of their failure, it's insufficient planning. So it's the lack of understanding the application dependencies before the applications are moved to the cloud. It's a lack of testing before they deploy and go live. It's a lack of, it's difficulties with consolidation and virtualization, and it's difficulties with cloud security. Okay. Well, the biggest question is how can we help fixing those? But before that, those issues would not be a big deal if they weren't costing a lot of money. And what is the cost of actually failing in migrating workloads to the cloud? Well, when we look at data points we've got, I mean, there are four kinds of costs attached to a cloud migration that actually doesn't deliver as expected. The first one is the fact that the migration process itself is expensive. When we look at data on that, we find out that migrating a single server is about $3,000. So when we consider migrating large data center operations to the cloud, we are actually considering a very costly operation. And if we have to revert basically that process or delay it, basically we increase that cost massively. The second cost stream will be the delay. So if we delay the migration, basically if we don't execute it on time, we are going to have to pay for the cost of maintaining two environments, basically your legacy environment and your target environment. And that will also incur extra labor costs. The third is the degradations. So basically when we migrate to the cost, then basically planning is not sufficient. We didn't understand all the consequences of migrating things to the cloud, or we don't do it in the proper way. There is a huge chance that we actually degrade the end user experience, either for your customers or for your internal users. But in all cases, that will translate into a loss, either in productivity, in revenue, or in loss in your customer base in churn, basically. And finally, and this is an extremely common pattern in cloud migrations, poor planning and poor preparations actually translate into unexpected cloud charges. As you know, basically when we move from an on-premise environment to a cloud environment, we change the cost paradigm in the sense that when we are working on-premise, we know exactly how much CapEx we spend for a given capacity overall, and that CapEx actually drives the OPEX or the maintenance OPEX attached to it. It's quite easy to predict what costs we are going to see in the coming years. When we move to the cloud, well, those costs becomes a lot harder to predict. And basically you can face totally unexpected cloud charges in terms of bandwidth, in terms of hosting, if you haven't planned exactly what bandwidth will be exchanged between the different regions or different VPCs, and what will be the hosting capacity that you'll need, and what will be the cost attached to it. So that's a lot of basically budget and money at stake, and being successful at migrating in the cloud is really something which, from an economic standpoint, is a big issue. So what are the steps to secure a cloud migration? So this is like an industry standard. This is not something we invented, but basically what we try to do is clarify what those steps are and show how performance visibility can help you go through each of those 6 steps. Okay? So basically, what are those steps? Number 1 is defining business goals. So as you probably know, a lot of cloud migrations are not decided at the IT infrastructure level. They are broader decisions which sometimes go beyond IT to actually achieve things that go beyond IT, like deploying new applications or deploying new services faster, or changing the model, or trying to digitalize the core business. So basically this is the starting point. This is a business goal. It turns into a second step, which will consist in discovering all the applications that are targeted by the migration, building a catalog, understanding what those applications are, then designing what the solution will be to host those applications in the cloud, testing and optimizing and refining basically the deployment model for those applications in the cloud, migrating the application workloads themselves, and finally moving to a monitoring stage where those applications are actually running in the cloud or fully in use, and we only need to make sure end user experiences is maintained to the highest possible level. Okay, so how do we do defining business goals? What are those goals? Well, the first thing is that there's no good migration that doesn't have clear business goals. So the first thing is identifying what those business goals are, and then mapping those business goals with IT capabilities and constraints. So capabilities can be basically how much resources you've got, what skills you've got, and basically what competencies are inside the team or needs to be gained. And constraints are external factors that will drive how you move to a cloud. So for example, there could be compliance, regulations that could be basically driven either by your industry or by your geography. And finally, you probably need to regroup and build a team that will involve all services to manage the migration process and prepare for it. Okay, so what are the typical goals organization try to pursue in migrating to the cloud? Well, the first one and most common one is robustness. So basically there is nothing that a classical organization could do from a robustness point of view that is achievable through the use of services like the ones of AWS, Google Cloud, or Azure. So basically you can benefit from that infrastructure, and it would be absolutely unthinkable for most organizations to actually reach the same level of robustness. The same thinking applies to scalability. Those cloud platforms basically allow organizations to get to a scalability in a short time frame that would not be reachable by classical on-premise data center technologies. Agility is the second one. Basically, you use a pre-existing architecture. You can use it and make it available instantly, so you can start using 100 times more resources in a very short time frame. You can start deploying workloads all over the world globally without any preparation, pretty much. Performance, there are multiple ways the cloud can help you reach your performance levels. Well, you've got access to more capacity, you can adjust that capacity, you basically have an elastic capacity that you can use to improve your performance. You can also use the global reach of the cloud to increase your performance. So that's the first way. Security, which work both ways. So certain companies actually consider that they take a security risk by moving to the cloud, but a lot of companies actually consider they reinforce security overall by using an infrastructure which is a lot more secured than what they could achieve internally. And finally, a lot of companies look for cost reduction. And cost reduction is actually a very interesting topic when we consider cloud migrations. Why is that? Because that's probably the number one item on the business goals, reducing cost. But reducing cost basically works provided you leverage the elasticity of the cloud. Otherwise, you would have to target very specific services to really reduce cost. And a lot of cloud migration failures are actually missing that objective of cost reduction and actually ending up spending more in the cloud than what the company was previously spending for their on-premise architecture. Okay, so how do we go around that? Once we've got the business goals defined and they are clear for the overall organization, what's the first step? Well, the first step is quite simple, and it's all about getting visibility on what we are going to move to the cloud. And getting visibility means, well, identifying all the applications in use, so knowing what is currently hosted in the legacy environment. What are the applications? And then for each application is understanding, qualifying it, understanding how critical it is from a business standpoint, how complex it is from an architecture point of view, what's the license cost attached to it, what's the hardware that is supporting it and that eventually needs to be renewed, and when, and what's the position of that application in the life cycle. So basically, is it an application which is old, which will need to be refactored? Is it an application which is almost new that went in production very recently and aligns with the business requirement very well? And the first thing will be, and that's the wisest way to approach a cloud migration, selecting the quick wins. So what are which applications should we migrate that are going to deliver massive benefits to our organization, either from a cost standpoint, from performance standpoint, from a scalability standpoint, from an agility standpoint, in the ability to deploy new services faster. Okay, but for that you need visibility. So that's where, I mean, the application of what we do and basically the performance visibility that SkyLIGHT can provide, what will it be? Well, it will be quite simple to implement. I mean, we'll just feed SkyLIGHT PVX with traffic entering your legacy data center, and instantly, and with no configuration, we'll get a view of all the applications that clients are accessing in the data center. We'll get a view of where those users are located and what's the volume of users for each of those applications, and what's the current user experience and performance profile. So when you access an application, you get to know what drives the performance or the end user experience. So if it's the network latency, if that application is actually transferring a lot of data, not a lot of data, if most of the application is driven by the performance of the servers themselves, etc. It's something we provide basically in a turnkey model where you actually implement the solution passively record the traffic, and from that traffic you get all of those statistics and analytics instantly. Moving to step 2, once we've decided which application we consider moving to the cloud, well, we will screen that application, and the thing we will be looking at is understanding what is the performance baseline. The performance baseline is pretty much the normal performance, so the starting point. And this will help us understand whether we've improved performance, we've degraded performance, and what could be driving that change. We'll understand the network requirements around that application, and this is important to size the network when we have moved to the cloud, which is one need, but it's also very important to understand what will be the bandwidth cost in the cloud of that application. And this is important to actually foresee exactly what's going to be the cost of running that application in the cloud. Then we'll try to identify the dependencies. What do we mean by dependencies? We mean that this application is normally composed of multiple elements in the data center. Those elements exchange data, and the bandwidth that correspond to those data exchanges actually translate into costs once you've moved into the cloud. So it's very important to know which systems needs to sit together from a latency standpoint, not to drive performance degradations, and also what's going to be the cost of maintaining those relationships in the cloud, and how we will configure basically the cloud along those. So how we do that? Well, simply in the same process. I mean, the passive traffic capture, and we'll get the baseline. So we'll understand the volume, the location of the users, their current user experience, and the drivers. Then the network requirements, through the same deployment, we'll understand what is the bandwidth of the overall application, what is the bandwidth per user, what's the seasonality and what's the usage profile, when are users using that application, what's the seasonality, does it change? And that will also drive the thinking around how much can we use the elasticity of the cloud to make savings or to improve the performance. And the geography will actually drive us to thinking like, can I use the cloud to actually basically make my content, my application available closer to the users or not? Application dependencies, well, as we did for the traffic coming in and out of the data center, we'll basically apply the same thinking to capture traffic inside the data center. And in that traffic, we will actually measure all the exchanges between the different servers, the front servers and the back-end servers, and understand the dependencies of the application to all the servers and all the services that can be called in the back-end. So we'll get a list of dependencies that will help us basically understand two things: understand what drives performance and what may drive future bandwidth impact. Okay. When we move to the third step, it's about designing the solution. So the first thing people do when they think of moving a specific a set of applications to the cloud, well, they usually refer to the 6 R's, basically 6 ways to migrate an application to the cloud. So the first one is called rehosting. It consists in basically moving an application as is from the legacy environment to the cloud. So it's really basically making no change and moving the virtual machines that are currently running in your virtual environment inside your private data center, and basically shifting them, lifting and shifting them to an infrastructure as a service environment like AWS, Azure, Google Cloud Computing, or whichever environment you choose. The second option is called replatforming. It's making very teeny changes when they are required. So basically not every application can be moved right away to an infrastructure as a service environment. So we slightly changed the architecture, but we don't rewrite the application. We just fine-tune it basically to make it suitable to run into an infrastructure as a service cloud. The third one consists in repurchasing. What is it? It's basically, for example, if an application is end of life, or if there is a massive incentive from an economic standpoint in replacing an application that we hosted in the private data center by a software as a service platform, where basically the organization doesn't have to take care of any infrastructure and application maintenance. That's called repurchasing. And it's basically replacing your current application by a service. The software as a service. The fourth is called refactoring or re-architecting. So this is really a more ambitious project. It consists in actually not reusing the software code we have, but actually rewriting that code or a large portion of the code to make the best possible use of the cloud technologies. So it could be rewriting everything and moving from a traditional application to a containerized application, to be able to move workloads basically to the cloud in a more flexible way, in a way which is more elastic, in a way which is going to be more economic, in a way that allow to be run in multiple cloud environments, for example, or simply hosting the code itself in the platform as a service environment, or using the DBA, the database as a service platforms that are offered by multiple clouds when it brings sufficient benefits. A fifth option that a lot of people forget is retiring. So basically when you find out and you discover that an application is used by a population of users which is so small that it makes no economic sense to maintain that application, you might just get rid of it. And finally, the sixth one is retaining. So in some cases, it is either not possible, or it makes no economic sense, or the timing in the life cycle is just not right to move that application to the cloud. And some people just maintain it in their on-premise data centers and make no change to it. Okay, so all of that will come from data that will be collected through interviews and internal knowledge about the applications, but also through findings that you get from performance visibility solutions like ours on, what is bandwidth, what is the architecture, and the dependencies inside the application, and the drivers from a performance standpoint in that application. Okay, once we've decided how we move which application, basically we'll go through a test and refine environment. So basically this will be the exercise we do in the sandbox when we start basically building a test environment for those applications. So we will evaluate the application behavior on-premise, do what we have to do to migrate it to the cloud, depending on what is the way we've chosen to migrate it to the cloud, which R we've chosen, and evaluate it again in the cloud and see what is the benefit or what is the cost from a performance standpoint. Then in the cloud, like anywhere, you've got multiple implementation options. So you can choose various ways to deploy that. You can use fast for a certain part of the application chain. You can start to deploy, for example, the front end in multiple geography, or actually centralize it. You can choose multiple ways to segment your cloud infrastructure in different VPCs or not. And those multiple options translate into different results from an economic standpoint and from an end user experience standpoint. It's actually very useful to get hot data on both the economics, so basically the traffic and the amount of where the traffic is flowing and how it translates into cost, and the hosting cost, and the end user experience. It's basically getting a measurement of that is going to be very helpful to choose what is the most adequate option for each application. And finally, when you start testing, hopefully, issues arise, and you get reports that there is a problem. Either there is a cost leak or a bandwidth that you did not suspect that actually occur, or there are degradations, and you've got to basically understand where it's coming from. So the kind of things you used to do in your on-premise on-premise environment need to be undertaken in the cloud, and you need to have tools that actually help you get to the root cause as fast as possible and understand what was the problem, and basically fine-tune your configuration based on those findings. Okay, how would we do that? Well, SkyLIGHT in the same way. I mean, just capturing traffic in the cloud as it does on-premise will show you exactly what bandwidth is used between the end users and the front servers, and from the front servers and the back-end servers, and what end user experience is delivered. So basically helping you understand both the cost side of things and the experience that you're giving, depending on the option you choose. Okay, and then we'll actually execute the migration. So basically, assuming you've chosen your application, you've chosen the way you deploy it, you've tested multiple ways or multiple implementation cases, you've chosen the right one, then comes the day where you actually press a button and say, we are going to migrate stuff. So how will you do that? I mean, the first thing you'll migrate will be the infrastructure. So anything, I mean, from a network standpoint, you'll need access, you'll need security infrastructure, you'll need load balancing infrastructure, and that's the first thing you'll deploy. And then you'll migrate the application workloads themselves. And finally, you'll go through the final testing and make sure everything works fine in production. How can we help you do that? Well, the first thing will be understanding the end-to-end performance and the impact of the infrastructure performance on the overall experience. So understand what is the latency from the user locations to the cloud, understanding whether the infrastructure located in the cloud delivers right on the performance, so whether the load balancers are working fine, whether your security infrastructure inside the cloud also delivers without having too much delay to the overall end user experience. And you will check the performance versus the initial baseline, making sure that you've got hot data to value how much you've improved the performance for the users, or if it has been degraded, why, and how you can go around that. Okay, and finally, we'll monitor the performance through the ramp-up. So as users add on, you will see how performance evolves. And finally, you move to production, and you drive in production because you've got hot data. You can drive performance optimization, find basically the most frequent transactions, the slowest ones, improve them. Keep resolution times under control, which may be an ability you've lost by moving from an on-premise environment with its own tool to the cloud. And you manage vendor costs and performance costs. Okay, how do you do that? Same thing, just by looking passively in the traffic, and you will get all of that data at the application level, at the cost level, at the network level, and that will help you actually understand what are the cloud cost drivers once you've moved your application. Okay, and finally, because I'm running out of time, basically, why are we well suited for that? Basically, because we've got that ability to expand the scope of performance visibility to whichever environment is needed. So basically, not only in the traditional data center, but also in the cloud, and taking that to east-west traffic, basically. Providing a tool that is capable of showing both end-user experience, network performance, and application performance in one tool, helping you rationalize basically the tools by having a tool which works across cloud and on-premise and delivers both network and application performance. Because it's extremely fast to deploy, and the adaptiveness of it and its architecture is well suited for the cloud visibility, because you can deploy as many probe as you want in multiple VPCs and basically it has no cost impact. And finally, it's non-intrusive, it's scalable, and natively designed for cloud and virtual environments. So I think I'll just flip through those slides and move on to the questions.
Thank you, Boris. That was a great presentation. Due to the time constraints, I think we'll only take one question for now, and we'll answer everybody's questions by email. Please feel free to send any questions to Boris's email at brogier@accedian.com. The first question we have is, what type of public cloud environments do you support?
Well, obviously, the solution is available in the two major marketplaces, so in Azure, AWS, but you can also implement it in many cloud provider environments because they run on the same type of infrastructure.